Hello and welcome, Bhaskar this side from Pharma Growth Hub. And I have a question for you. So, would you like to save some solvent for your lab during HPLC analysis? And I'm sure the obvious answer from your side could be yes, Bhaskar, I would like to save some solvent. So, how one can save the solvent during the HPLC analysis is going to be the topic for today's discussion. And I hope you will get some very useful information as a part of this discussion. So the purpose of using the solvent is during HPLC analysis is to make sure that your compound gets out of the column. It's get detected by using the detector that you are using. So there are two important parameters that we are going to discuss today. The first one is column diameter. So how the column diameter can influence onto the solvent consumption. And again, the second parameter is going to be the length of your HPLC column, because these two parameters, I mean these two dimensions of the column, can certainly impact the solvent consumption or your mobile phase consumption. So the first point, let us talk about the column diameter. So it has been very obvious to understand that the smaller is the column diameter, the smaller is going to be the consumption of the mobile phase or the solvent. But I would like you to quantify this, the saving, so that you will be able to convince yourself, your team on using the small diameter HPLC column. So for an example, please consider that in case if you are using 4.6 mm diameter column and you want to switch to, let us say, 4 mm diameter column. So in case if you make this change from 4.6 mm to 4 mm, let us now understand how this solvent saving is going to happen. So just assume that the flow rate of your 4.6 mm column is 4.6 mm diameter column is 1 ml per minute. So to achieve the similar kind of retention, you have to adjust the flow rate to 0.76 ml per minute. Now with this, you must understand that as this flow rate has got reduced, obviously the consumption of the solvent is also going to be reduced. So the relative sensitivity will get increased by 1.32 times, and this is the theoretical value. This can be lower or higher, but you can certainly get assured that the sensitivity for your analyte will certainly get increased once you decrease the diameter of the column. The sample load will get reduced, because now the available surface area will get reduced because of the lower diameter column, and hence you may have to compromise a little onto the sample load, but that should not become the more worry as your sensitivity has increased with the good fold of the time. But the more interesting part to understand that, the relative solvent saving. You are going to save 24% of your consumption just by switching the inner diameter from 4.6 mm to 4 mm. Further, let us understand in case if you want to use 3 mm inner diameter column, how much is going to be the saving? It is almost going to be a 57% saving, and it's a good amount of saving as per as the HPLC consumables or your lab expenses are concerned, because many a times the all solvents used for HPLC analysis are going to be HPLC grade or even equivalent or better than that, and that comes with a lot of cost, isn't it? So 57% saving is a good amount of saving. And in case if you have the column in a diameter of 2 mm, then the 81% can be saved on. So these assumptions has been made with the point that the column length is going to be the same. So assume the same column length containing the same packing. So you are not going to change any kind of your stationary phase. It is going to remain the same. So for understanding the calculation details, I have given into the respective column, like the relative flow rate calculation, the relative sensitivity per same sample load calculation, relative sample load calculation, and finally how I have calculated the relative solvent saving part. So in case if you want to propose the shorter diameter column, you have the better chance just right now. So this is just the one factor, and please also understand that with this column diameter factor, the increase in sensitivity is just a theoretical part. I have shown over here with the calculation that the sensitivity get increased with the decrease in the inner diameter, but the actual gain will dependent on the extra column band spreading of the peak caused by tubing volume and flow cell geometry. So you need to also understand that the tubing should also get thinner as you are moving towards the lesser diameter inner column. So that can also have the influence onto the sensitivity or the response of your analyte. I hope you will find the first point very useful. Let us talk about the second parameter, that is the column length now. So how this column length will help us to reduce the solvent cost. So just assume that the you are using 25 centimeter column, and in case if you are having the flow rate of 1 ml per minute, if you use the 15 centimeter column, right, to get the similar kind of retention time, you have to adjust the flow rate to 0.6 ml per minute. See, now with the decrease in flow rate, one can easily understand that the solvent consumption is also going to get decreased, and you will not get compromised onto the your retention time. But also understand that in case if there is a resolution criticality, and if it is only dependent on to the column length, probably you may have to face some challenges. So because once you reduce the column length, your resolution may also get reduced. So in case if there is no resolution concern, I can propose you to decrease the column length also. So with the decrease in column length, you can certainly save this much amount of the solvents cost. So with the 15 centimeter column, you are going to save 40% of the solvent consumption. With the 10 centimeter column, you are going to save almost 60% of the solvent consumption. And with the 5 centimeter column, you are going to save almost 80% of your solvent consumption. Please understand, this comparison is made with the 25 centimeter column. Hmm? So 25 centimeter column is considered, and against that I have calculated the solvent saving for 15 centimeter, for 10 centimeter, for 5 centimeter. And as I said, this can be used in case if the resolution is not the critical. See, most of the times, if you are using the dissolution analysis or many times content uniformity or sometimes assay analysis, this resolution may not be the critical parameter, isn't it? So in those analyses, you can certainly use the smaller length columns, the column having the smaller length and also the column having the smaller diameter. So these are the two important parameters which are certainly going to help us in reducing our solvent cost. I hope you will be able to implement this in practical, and please do revert in case if you found this video useful. Thank you so much.